A Wimshurst machine is an instrument named after the British inventor James Wimshurst, who developed it in the early 1880s for generating high-voltage electricity. A well-designed machine could easily generate a potential difference of up to 50 or 60,000 volts.
A Wimshurst generator belongs to a class of electrostatic generators called influence machines. James Wimshurst became interested in studying influence machines in the late 1800s. Wimshurst lived in England. Here he had a versatile workshop which had a variety of tools and devices for electric illumination. Wimshurst constructed several of the known types of electrostatic generators, such as those created by Nicholson, Carr, and Holtz. To these predecessors, Wimshurst made many modifications, with the result known as the Holtz-Wimshurst machine.
Shortly thereafter, Wimshurst created another design, the duplex machine. The device had two discs turning in opposite directions, with metallic conducting sectors on the surfaces of each. Compared to its predecessors, this machine was less sensitive to atmospheric conditions and did not require an electric power supply.
The way we built the structure was by using wood for the support and the base. We attached the support beams to the base by screwing them in 3 times on each side in order to ensure their stability. We also added wood glue to ensure more stability. These wood blocks were also added to the dowels to prevent movement. This hot glue ring was also made for minimal sliding. We demonstrate how the charge goes through the wires, first through the collectors down to the capacitor. Here we see a small disc on the bottom and a large disc on the top that are used through a pulley system to create charge. For the reality, we use cardboard as the replica for the small discs and CDs as a replica for the large discs with aluminum sectors on them to create part of a circuit. Here on the expectations, we see one straight string and one cross string. This is necessary in order for the disc to spin in opposite directions to create charge. With Stuart, we did the same thing with one cross string and one straight string to ensure that they moved in opposite directions. Here we see one brush on the bottom and one brush on the top that are exactly opposite each other. Attach the brushes to the neutralizer bar in the same way, making them exactly opposite to each other to create an electrical circuit. They are also turned in the direction of the spinning to prevent disruption. Here on the expectations, we see the support bar that is holding the electrodes that is creating the spark. Ours, you see similar support bar holding the wires that transport our charge. Collectors are meant to collect charge, as you can see here, as they rub along the sectors on the large disc. On ours, we attempted the same collectors by using wires and taking off some of the insulation to help with conductivity. On Harrison, our expectations generator, these Leyden jars held the charge being delivered throughout the machine, aka their capacitor. For Stuart, our reality, we unfortunately did not have Leyden jars, so we used a CD case and aluminum foil to create a capacitor. For Harrison, the expectations were met and a spark was created, showing a generation of electricity. For Stuart, we tried to replicate that spark gap and it worked. Actually, we really didn't create a spark, but we were still able to create some voltage as seen here.